So in continuation with the video 2, we have discussed where we had discussed about the single covalent bond in which you have seen in hydrogen and chlorine. Now we will see double covalent bond in oxygen molecule. The atomic number of oxygen is 8, electronic configuration 2 6. It has 6 valence electrons and it needs 2 electrons more to attain stability. So because the K shell, L shell has L shell, you need 8 electrons for attaining stability. So two oxygen atoms share pairs of electrons resulting in the formation of double covalent bond in oxygen molecule. Oxygen, the valence electrons 2, 4, 6, another oxygen atom 2, 4, 6. So these two electrons from this oxygen is sharing with the other 2 electrons of the other atom. So if you see, this oxygen atom has now 8 electrons in the valence shell. 2, 4, 6, 8. Here 2, 4, 6, 8. That is, it has shared 2 electrons. Oxygen has shared. This oxygen atom has shared 2 electrons with this oxygen atom, forming oxygen molecule. So it is a double covalent bond where it has shared 2 electrons. Let's see the formation of triple covalent bond in nitrogen molecule N2. The atomic number of nitrogen is 7. Its electronic configuration is 2 5 and valence electrons 5. It needs 3 electrons more to attain stability. 5. You need 3 more electrons. So 2 nitrogen atoms share 3 pairs of electrons, resulting in the formation of a triple covalent bond in nitrogen molecule. In nitrogen atom, you have 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. Two nitrogen atoms, when they combine, they share 3 electrons here with the other nitrogen atoms. So altogether here nitrogen has 8 electrons. This nitrogen has 8 electrons. So it has attained stability, forming nitrogen molecule. So it is shared by triple covalent bond. Shared by 3 electrons, forming triple covalent bond. Next one, whatever we have done, I have given few more examples. Single covalent bond, we have already explained about the formation of hydrogen molecule. Then one more example, chlorine. Chlorine atomic number 17, electronic configuration 287, number of valence electrons 7. So you have 2 electrons here, 2 electrons here, 2 electrons and 1 electron, total 7. Here also 7 electrons. The 1 electron is being shared, forming, now we have 2, 4, 6, 8. This chlorine atom has attained stability. This one also has 8 electrons. So they have shared 1 electron. So this is an example of single covalent bond, one single line. Double covalent bond, when 2 pairs of electrons are shared with 2 atoms in a molecule. Oxygen we have discussed in the previous slide. Now I'm giving another example for carbon dioxide. So oxygen atomic valence electrons is 6, electronic configuration 2 6. So 2 4 6, and carbon has 4, so it has shared 2 electrons with here and 2 electrons here. So altogether oxygen has 8 electrons, carbon has 8 electrons, 2 plus 2 4 6 8. Here oxygen also 2 4 6 8. So carbon has bonded with oxygen with oxygen. 2 electrons have been shared here, 2 electrons have been shared, forming carbon dioxide. Now triple covalent bond, an example, when 3 pairs of electrons are shared between 2 atoms in a molecule, example nitrogen. So atomic number 7, number of valence electrons 5, electronic configuration is 2 and 5. See, nitrogen atom 5 electrons in the valence shell, 2 plus 3 5, 2 plus 3 5. So these 3 electrons from each nitrogen have been shared. So 3 pairs of electrons have been shared here, forming a triple bond. See 3 lines here. Here you have 2 lines. Here you have single line which represent the bonding. Then we have the or, hydrocarbons. First one, formation of methane molecule. Methane. So atomic number, here is carbon is 6. Number of atomic number of hydrogen is 1. So how it has shared? Carbon has shared 1 electron with this hydrogen, this one, and 1, here 1, here 1. So this carbon has 2 electrons here. Carbon has attained stability here, has attained stability here. This one also attained stability. So this carbon here has attained total of 8 electrons, 2, 4, 6, 8. So this compound is called methane molecule. Then another example, formation of, this is also single covalent bond. This is formation of hydrogen sulfide molecule. See sulfur atomic number 16286 and valence electrons is 6. So hydrogen 1 electron from this sulfur. Here hydrogen 1 electron, 1 from sulfur. Sulfur has 2, 4, 5 and 6. So now hydrogen has 2, sulfur has 8 and hydrogen has again 2. So it has shared 1 electron here, 1 electron here. So that is a single covalent bond. Now let's see the physical properties of organic compound. Most of the organic compounds have low boiling point and melting point due to the weak force of attraction, that is the intermolecular force of attraction between these molecules. So because of the weak force of attraction, intermolecular force of attraction, it has low boiling point and melting point. Most of the carbon compounds are poor conductors of electricity due to the absence of electrons and free ions. It doesn't have free electrons and free ions. Next one is the electron dot structure. Let's see. The electron dot structure provides a picture of bonding in molecules in terms of shared pairs of electrons and octet rule. Octet rule is attaining stability. The valence shell should be complete. Then this rule is called octet rule. Now electron dot structure of hydrocarbons. First one is methane, then you have ethane, then you have propane. See methane. Methane means one carbon atom. Share we have discussed in the previous slide. A single bond here, single bond here, single bond here. This is methane. N is equal to 1. N means number of carbon atom is 1. Ethane, ETH. So here then it is wrong here. N is 2. N is 2 here. C. Propane. N is 3. 1, 2, 3. So it has how many electrons? 1, 2, 3, 4, 5. Sorry, how many hydrogen atoms? 1, 2, 3, 4, 5, 6, 7, 8. So propane structural formula here C3H8. Here ethane C2H6. 1, 2, 3, 4, 5, 6. This is the structure. There is a mistake here. This is 2 here. Then electron dot structure of ethane. This is your carbon atom with 1 electron each on all the 4. It is sharing one hydrogen electron with this hydrogen atom, and this hydrogen atom. One electron is being shared with the other carbon atom. This carbon atom again sharing one electron here, one electron here, one electron here, one electron with the other carbon atom. So this is having 8 here, this is having 8 here, electrons here, 1, 2, 2, 2, 2, 2. So 2 electrons, 2 carbon atoms, C2, H6. So H6. Now let's see the electron dot structure of propane. Prop means there should be 3 carbon atoms. So here also this carbon has shared 1 electron with this hydrogen, second hydrogen, third hydrogen, fourth it has shared with this carbon. This carbon has shared 1 electron with this carbon, this carbon, one electron with this hydrogen, one electron with this hydrogen. This carbon shared one electron here with this carbon, one electron with this hydrogen, one electron with this hydrogen and this hydrogen. So electron dot structure is propane. Of propane is C3H8. 1, 2, 3, 3, 4, 5, 6, 7, 8. This is how you write the form. Now there are some examples. See, hydrogen, we have explained how it forms hydrogen molecule sharing one electron. Fluorine. Fluorine atomic number is 9, so 2, 7. So valence shell has 7 electrons here, 7 electrons. They share one electron each other, forming fluorine F2. Oxygen, carbon dioxide, we have already discussed how carbon share share 2 electrons with this oxygen, 2 electrons with this oxygen. Now you have fluorine. Fluorine, how many fluorine atoms? There are 4 fluorine atoms here, 2 carbon atoms. Fluorine, 1 carbon atom. So here the atomic number, it shares 1 electron here, 1 electron here, and 1 electron here, 1 electron here. So fluorine has now 2, 4, 6, 8. Here also it has got 8. The atomic number of fluorine is 9. So number of valence electrons will be 7. So it needs 1 electron here. They share each other. Carbon, these 2 carbon and fluorine, they share. These 2 carbon and fluorine, it will share. These 2 will share, forming a stable structure, and you're getting carbon tetrafluoride CF4.